Welcome guys to this video on AirBnB clone the console. So I'm just going to start with task 3. That's where the venting started. So we have to write a class based model that defines all common attributes for other classes. And the public instance attribute should be ID, starting with a UUID when an instance is created. The UUID will generate a unique number. So then when we create it, we should convert it to a string. We should have created that will have the date time assigned at the current date time when the instance is created. Same thing with updated that. Okay, let's do this. And then so with my AirBnB clone folder, and I've already created my models directory and my test directory. So I'm going to go ahead to open base model.py inside models directory. So I'm not going to be doing all these all these things. So you have to take care of these things on your own. So I just want to focus on the task. What we have to do is to first import UUID, then also import date time from date time, and then we're going to create the class base model. So as we already know, this base model is going to be a class that serves as the base for other classes in our application, the classes that we are here to create. So next is to create the constructor for base model, which is going to be called whenever a new instance of base model is created. So next thing, we are asked to assign a unique identifier, that is UUID, which is so generated using UID. So we just say self.id is equal to UUID.UUID4, and don't forget we were asked to convert it to a string. So we call the string function. So and then we need to created that attribute and updated that attribute. So we initialize both of them with the current date time. So solve that created that is equal to date time dot UTC. Now same thing with self dot updated that equal to datetime dot UTC. Now okay, that out of the way, let's got the next thing. Okay, we should do this. Okay, let's do save first. We should update the public instance attribute, updated that with the current date time. So create the save method passing itself. So this save method is going to be what it's doing is to update this updated attribute with the current date time whenever we call the save method. So we just say save dot updated that equal to datetime.utc. Now, so the use of this method is to mark when the object or the instance was last updated. So calling the save method will change the value of updated that from the initial datetime, that is from the value, the datetime it was when the instance was created, to the datetime when the save method was called. So let's see again. Next one is to dict method, which is going to return dictionary containing all keys and values of this inbuilt dict attribute of the instance by using self.dict. Okay, we should return a key class created that and updated that, and it should be with this time format. So we use ISO format to convert it to this time format. So what we are going to do method, that's like serialization, turning to object into the instance to a dictionary. So we say def to dict passing self. So we say instance dictionary is equal to, we are asked to use self.dict self.dict. So if this self.dict attribute is a built-in Python feature that allows us to access and manipulate an object's attributes, or say an instance attribute, as if they were stored in a dictionary. It's like looking at an object's variable names as a key, while the values are the corresponding values to the key, like a dictionary. And again, this self.dict is automatically created for every instance of a class. So we say self.dict copy. So what we're doing here is we are just making a copy of the dictionary representation of any instance that is created. And then we've been asked to create make a copy, and then we create a key. The key is going to be the class name, and the value is going to be the class name. And then okay, let's just do it. We say instance dictionary, then we create a key, and this key is going to be class, and the value is going to be the class name. Value is going to be the class name. So that is here the dictionary could be something like, let's see, could be something like class, and the value would be an instance, let's see, my model, just like that. So next we create a key for created that, and then create a key for updated that. So we say inst dict, the key is going to be created that, and the value is going to be self.dict. created that. And don't forget, we have to turn it to this format using the ISO format of datetime object. So we say dot ISO format. So we do the same for updated that. Say ins dictionary. We create a key for updated that, and we assign a value as updated that, and then change it to the required format using the ISO format of datetime. Then finally we return ins dictionary. So let's make something clear why we can access an instance attribute using self.dict. It doesn't mean that every class is a dictionary. The self.dict is an inbuilt attribute. It is just a way to interact with the attributes of an instance in a dictionary-like fashion. So it is an attribute itself, only that it is created by Python when an instance is created. So when we use self.dict.copy in the context of this serialization, serializing an object in the dict method, what we are doing is we are creating a copy of the dictionary that holds the instance attribute. So this copy is meant to avoid altering the actual attributes of the object and to maintain data integrity during the serialization process. And then also it's a way to work with the object's attributes in a safe and non-destructive manner for purposes like creating a dictionary representation of the object. Just up on your screen is a video where I thoroughly explained this. You can go ahead and check it out by clicking on it. So the next thing we do is to okay, now we've done this part, we need to create another method for string representation of the class. So we say def, and then we pass in self. So this string method is going to be for creating the object of the instance, any instance or object that we create. So we say, so we are told to return, we should have class name, you should have class name followed by the ID and then the dictionary representation. But when we do the dictionary representation, is going to be a string. So we say first we create class name, which is self dot class dot name, and then we say return. So I guess it started with this and then this, followed by we are using the string format. So yeah. Now we pass in this class name first, followed by self.id and then self.dictionary. So what we will do is to return a formatted string that includes the class name, the ID attribute, and the string representation of the dictionary attribute, which contains all the instances attributes and their value. So it will say like base model followed by ID, and then it follows by string model ID, created that, updated that, any other thing that is added to it. So overall, this base model class can be used as a base for other classes in our application, allowing us to inherit its attributes and methods for common functionality, such as generating unique identifiers, managing creation and update times, and providing serialization capabilities. So let me just, I'll fast forward this side, add the what we're supposed to use to test it to my main. I usually do just, yeah. So let's run. Okay. Alright, it's typical me. I always make typos. Typing T. Okay. What happened here? Okay. My bad. Okay. So there we have it. And then, of course, we have to write a test for this base model. So bi test slash test model slash test base model +5. Okay. So for the test parts, we import unit test, and then from models dot base model, we import base model. Yes. Okay. And then we create test class. It's called the test base model, and it's going to inherit from unit test dot test case. Okay. Then first thing we are going to test is the init, the constructor of the base model. So we say test init. So to test the init, we first initialize an instance of the base model. Say my model equal to base model, and then by doing so, we have ensured that the ID, created that, and updated that attributes are now with values. So next thing we do is to test if they indeed have values. So we say self dot assert is none, is not, should be is not none, because what we want to do is to assert that they are now with values, they are not none. So we say my model dot id. So this is supposed to be true. Same thing we say we do it for my model dot created at. Then we do it for my model dot updated at. So when we run this test, it should pass because all of the values of the attributes should not be none. And then next is to test the save method. So we say test save passing self. So again, we create an instance of base model. So now remember that the updated that attribute, you have the current date time when the instance of this base model is created. So you create a variable called initial updated that and set it to my model dot updated that. So what we did here is to initialize updated that as the value when the instance was created. So next thing we are going to do is now we are going to call the save method, and the save method is going to give the updated that attribute a new value, and we are going to save it to another variable called current updated that. So we say current updated that is equal to, we call the save method my model dot save. Now initial updated that has the value of updated that attribute when this instance was created. Now the current updated that has the current value of updated that when we call the save method. So remember that the save method updates the updated attribute with the current time, date time. So now what we do next is to assert that both of them are not equal. The time should not be equal because the updated that when we created the instance and when we call the save method are no longer the same because they've been changed. So we say initial updated that should not be equal with the current updated that. So this should return true. Then that is it for save, because we only have one thing there. So next thing we are going to test is the toDict method. So we say text toDict passing self. Again, we create an instance of base model. Again, we will serialize the instance of the dictionary using the toDict method. So we say my, that is calling to dict method and saving it to a variable. That's what I mean by to serialize the instance of the dictionary to a dictionary. So you say my model dictionary is equal to recall my model dot to dict my model to dict. So the next thing we are going to do is to ensure that the serialization worked by checking if my model dict is indeed a dictionary, by checking if this indeed is a dictionary, because we've serialized my model, this instance, to a dictionary by calling to dict method and giving it to the variable my model dict. So we say self dot assert is instance okay, assert is instance. We assert that my model dict is an instance of a dictionary. This should return true. Then the next thing we start doing is to assert that the instant dictionary has a key class with the name of the class as the value. Because remember, when we were serializing, the class is the key and the class name is the value. ID is the key, the self.id is the value. Created that is the key, created that self.created that is the value, just like that. So we start with self.assert equal. So I'm going to copy this how many times? I think 3 times, 4 times. So first, what we check is that there is a key class with the name of the class as the value. So we say my model dict, and then the key, there should be a key, and then the value should be name of the class base model. So the same thing, copy this too. We check for the key ID, my model dot ID should be the value. We paste again. We check for the key created at, we should have self dot created that dot iso format as value, but here we have an instance my model dot created that dot iso format. So we paste this again. We are looking for updated that. Let me correct this. Looking for updated that as the key, and has to be my model dot created that dot so format. Okay, so this should also return true. And then the last test to do is the string method. You have to test it. Say test string, and we create an instance. My model is equal to base model. So we know that when we create an instance of the base model and print it, it should start with base model inside the square brace, just the way we set it in the string method. So we have to confirm that, we have to test that it does. So we say self dot assert true that my model, I think you need to first convert it to a string, because what we are testing is the string representation. So we say the string representation of my model should start with, we use the start with function, that is, it should start with base model inside the square brace, base model. This should return true. And then we know that the instance created should have an ID, so we assert that it is present in the string representation. So we say self dot assert in, we assert that my model dot ID indeed is in the string representation of my model. It should return true. And then we also know that the dictionary representation of the created that instance should be in the string method, that is in the string format. So we assert that it is present too. So we say self dot assert in, we have to assert that the model, the instance, the object has a dictionary representation, which is a string in the string method. So of course we have to first convert it to a string before checking. We say my model dot dict is present in the string representation of my model. So of course we say if so unit test dot main. So let me test now. Unit test okay. First I'll do so in our test models we have init.py, and also inside our test folder we have the init.py, and also in our root folder we have init.py. So again, let's run the test. It's updated that. So yeah, round 4 test. Alright, so I'm going to have to be doing this maybe a video at a time because I believe it's going to be taking too long. So if you have the strength, you can go on and watch.